All right, last problem, number 20. A rectangle is inscribed underneath the graph of y equals 2 times the square root of negative x plus 10, with its left side on the y-axis, its base on the x-axis, and its upper right endpoint, should say upper right vertex, on the graph of y. Find the dimensions of the maximum rectangle. So picture what this looks like. We have this graph, which is going to look something like that, and we have a rectangle underneath it, just like that, or something like that. We don't know the specifics of it. Maybe it looks like that, maybe it looks more like that. We don't know, but we know its upper right endpoint is on there. That's all we know, and we want to find the dimensions. So let's think about then what the different pieces represent. If we think of the area of this, well, the area is going to be that dimension right there, which, if that's the origin with an x value of 0, then this point right here has some x value we don't know, so we're just going to call that x. Now then, what is the height of that rectangle? Well, since that point is on the graph, the height is just your equation of y, 2 times the square root of negative x plus 10. So if we're finding the area of that rectangle, area equals just x times that equation. So I'm going to write that as 2x times the square root of negative x plus 10. Now I want to graph this equation. So enter that into your calculator. If you're on an old TI-83, type it as 2x, then do your square root. It gives you that parenthesis. Type negative x plus 10, and then close that parenthesis off, and that should get you the correct graph. But we need to find ourselves a good window. So again, our technique so far has been to take whatever it is we're substituting into our area equation, which is, in this instance, that equation right there. Take that, 2 times the square root of negative x plus 10, and set that equal to 0. Well, let's divide by 2 on both sides. Okay, 0 divided by 2 is 0, so that 2 is gone. Let's then square both sides. Okay, well, 0 squared is still 0, so that square root's gone. So really, all that matters is what's inside the square root. So we have negative x plus 10 equals 0. So add x to both sides to get 10 equals x. That's telling me that my x maximum on my window should be 10. X min, set that equal to 0. And once you've done that, hit the zoom button and hit the option 0, which is a zoom fit. That will get you a perfect window, and it'll give you a graph that looks like something like that. Keep in mind it's different than the actual graph of the equation, that green graph up above. This graph represents the area. Our y values are the area. Our x values are those same x values, the dimension of that rectangle. So we want to find this maximum value right there, and so we need to use our calculator. So pull that calculator out. Pull that calculator out. Let me clear this stuff off real quick. What do we need to do? Well, we need to calculate a maximum value. So once you're on your graph, hit second, and then hit the calculate button, which is the same as the trace, and choose option 4 for a maximum value. So again, we're looking at this graph like that. Now, first thing it's going to say on there is left bound with a question mark. We just want to choose any point that is to the left of that maximum value. We know that 0 is to the left of it, so if you just type in 0 and hit enter, it will choose that as your left boundary. So hit 0, hit enter, and from the algebra we did earlier, we know that 10 is to the right of it. We're looking at both of those zeros right there. So when it says right bound, type 10, hit enter. When it asks you to guess, just hit enter again, and it will tell you that x equals 6.666. And it probably is exactly 6 2/3, but can't really tell for certain based off of this, because your calculator always does have a little bit of a rounding error. But we can take that x value and we can use it, whoops, didn't mean to do that, we can use it to find the y value. Because your calculator will say that the y value is 24.343, but again, that represents the area. So we now need to plug this x value back into our equation to find y, the height of our rectangle. So y is going to equal 2 times the square root of negative 6.666 plus 10. We're just plugging back into that original equation to find that y is roughly 3.65, and I'm going to say 2. If you used 6.666, it will say 148, which you would round to 651. But if you use the exact value and just type the x that's stored after finding the maximum value, you get 3.65148, which would not be rounded. If you rounded the 6.66, you get 3.65184, which would go to 652. But either way, 1,000ths place like that, not a huge deal, but we have our value right there for y. So we have our dimensions x and y, and we know that the maximum area was 24 point blah 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 blah.